Hello chemistry fans, and welcome back to Chemistry 1032 problem solving session here at the Academic Success Center on Broward College North Campus. I am your host, Dr. Russell Betts, and I'll be guiding you through this problem today. So let's jump right in. Chapter 10, problem 8. A 25 milliliter sample of HBr solution is titrated to the endpoint using 15.4 milliliters of a 0.200 molar solution of KOH. What is the concentration of the HBr solution in molarity? All right. Okay, these questions are not hard. They only look hard, but they're really not. You just have to be careful and keep your numbers straight. So now, when I do these questions, I like to set up a little table. So over here under my expression of my balanced equation, this is a balanced equation, I will write molarity, volume, moles. I just like to do that to keep my numbers straight. And if you want, you can put a couple of little dotted lines here to kind of keep everybody separated. You know, make a little table. You might want to use a ruler if you have one. There, it's not bad for freehand, I guess. Now, let's put in our numbers in our table so we can keep everybody straight, everybody happy. All right, 25 milliliter sample of KBr solution. Okay, so 25 milliliters, it goes here. 25 milliliters goes there, is titrated to the endpoint using 15.4 milliliters of KOH. So 15.4 milliliters goes there, and 0.200 molar goes there. And we want the HBr solution's concentration. So now, we have molarity. So molarity, let's just define it, is moles solute over liters solution. All right, so that's a basic molarity question. Okay, so now we need to know the concentration of HBr, but we don't know it. We also don't know the moles, so we can't figure out molarity here. But we do know the concentration of KOH and the volume required to neutralize this solution. And we have a balanced equation. So let's look at the balanced equation real quick. We know that 1 mole of HBr equals 1 mole of KOH. So let's write that down. 1 mole So this is an equality. So we have an equality. So wait now. If we know the relationship between HBr and KOH, the equality here, right here, if we knew the moles of KOH, we could use this expression to figure out the moles of HBr. Right? Let's say that again. This is an equality. This is basically a conversion factor. If we know the moles of KOH, we can determine the moles of HBr using this equality. Well, that makes this question easy. All we got to do is figure out the moles of this, convert it to the moles of that, and calculate molarity, because we have volume, it's right there. This question became infinitely easier than we thought it was going to be. All right, so let's calculate the moles of KOH. Because if we can figure out these moles, boy, we can figure out those moles right there. Excellent. All right, so we know we have molarity equals moles over liters. So moles equals molarity multiplied by liters. I just rearranged that expression real quick. Equals, the molarity is 0.200 moles per liter. That's just molarity right there. That's just capital M. I just put it in the units. So let me just do this. Capital M equals that right there. Multiplied by, now we're in milliliters. So let's quickly convert that to liters. It'll be 0.0154 liters. So liters will cancel now, giving us, bust out the calculator, 0.2 multiplied by 0.0154 equals 0.00308 moles. Moles of KOH. All right? So now, we know the moles of KOH. We can use this expression right there to determine the moles of HBr. All right? Calculate moles of HBr. Well, we know the moles, KOH, multiplied by something will give us moles, HBr. All right, so far so good, right guys? We'll put the moles, KOH right here, moles, HBr right there. Moles of KOH will cancel. We know the moles over here. It's 0.00308 moles of KOH. We know it's 1 mole HBr, 1 mole KOH. Now, this is nice because it was a 1-to-1 relationship in the balanced equation. It doesn't have to be 1-to-1. It could have been 1-to-2 or even 1-to-3, depending on the acid we chose to use, or the base. We could have chose a different base and the balanced equation would not have been 1-to-1. So this is important to recognize this. It could have been 2-to-1 or 1-to-2. So it doesn't matter as long as you know this expression here, which you get from the balanced equation. So these may change depending on the acid or base used up here. Okay, so now this is going to be 0.00308 moles of HBr. Okay? And that's because it was a 1-to-1 relationship, because of the balanced equation. Okay? Now, last step, molarity, HBr. Molarity equals moles by liters. So it's going to be 0.00308 moles divided by, now, here's our volume in milliliters, so you got to convert it to liters, 0.0250 liters equals 0.00308 divided by 0.0250 equals. The final answer is 0.123 molar. All right? Now, this is a lot. This is a lot of keeping numbers straight. It's a lot of moving numbers around. It's a lot. And probably your first time attempting this problem, you probably had a hard time with it. That's okay. Try again. And if you still have a hard time, try again. These questions become easier the more you try. Now, you might get it wrong 3 or 4 times. You might get stuck 3 or 4 times. You might even get discouraged. Don't let that stop you. You're learning how to do it. Now, I wasn't good at it the first time doing it. It took me probably a couple days to figure this out, to be able to do it. So it takes you a couple days, so be it. But don't sit back on this. This is a very important thing to do. You may want to watch this video again, just to make sure that you've got it straight. Once you think you've got it straight, cover up my answer, cover up your answer. Try working through it on your own without any help. If you can get through it without any help at all, you've got it. Okay? But don't sit back. Don't just say, oh, well, it's not that important, because it is. Okay? These are very fundamental questions in chemistry. They tell your professor if you understand a lot of fundamental concepts. They also tell us, can you use units? Can you force your way through a problem just using units? Because that's all I did. I just used units for the whole question. All right? Now, if you have any trouble with this and you want help, don't hesitate to come and find me during office hours if you're one of my students, or your own professor if you want. Or there's plenty of tutors here at the Academic Success Center that are more than willing and more than able to help you with this and may give you a nice insight into how they approach these problems. but don't sit back on it, okay? Now with that, I'd like to wish you good luck and good chemistry.